Okay, I'm back again. This time I would like to take a shot at 103 the way I suggested we do it. Please notice here is all the work that went into 103, a more traditional method. I would like to look at a simpler way of looking at things. For part A, we had that the velocity was doubling. Okay, the velocity was going from v initial to 2v initial. And we are interested in figuring out what happens to delta t. Now, this is an up and down problem, so of course we have that the acceleration is equal to g. All right. Do we have anything else? Sure we do. This is an up and down problem, which means v final is equal to negative of v initial. So now we're going to combine a statement that deals with v initial, acceleration, v final, acceleration, v initial, and delta t. That's vvat. So we have v final equals v initial plus the acceleration, which in this case, because it's up and down, is g, multiplied by our time interval. We make a substitution here. Negative v initial is equal to v initial plus g times delta t. Solving this for delta t, we get delta t is equal to negative 2v initial divided by g. All right. Now, negative 2 is not going to change. G is not going to change. That means that these two things are a constant. So what I have is delta t is equal to a constant multiplied by v initial. That means that they are directly proportional. Or if I were to double, that's not an x, that means multiply by 2. If I were to double v initial, because it is in the numerator and it's just multiplied by a constant, it is going to do the same thing to delta t. So what has happened is delta t doubles because it ends up being multiplied by 2. Let's look at the trickier one. For part B, we have, again, v initial going to twice v initial, but we also just figured out that delta t is going to double the delta t. All right. So we have two changes that are happening at once, and we would like to know what does this do to our maximum height, y maximum. Now, y maximum is also equal to the displacement on the way up. That's what I'm going to concentrate on. So I do have time. I have v initial. Oh, I also, since it's at the top, I know that v final is equal to 0. So I would like something that matches up with all of those guys. And so I want a displacement formula. And once again, I would kind of like to stay away from the one that has time getting squared because it may confuse the issue. So I'm going to go back to the averages. And so my displacement in the y direction is equal to the average of my final velocity and my initial velocity. So the two of them added up and divided by 2. Multiplied by my change in time. All right, I want to solve this for, well, it's already solved for delta y, isn't it? We just need to make a substitution or two. We know that v final is 0, so we can clean this up a little bit, and we can say that v initial multiplied by delta t divided by 2 is equal to delta y. 2 is not going to change. It is, again, the constant that's out in front of these variables that are allowed to shift. So what essentially we have is we have 1/2 times v initial and the change in time. Since this one is doubling, and this one is doubling. The net effect is going to be that you are quadrupling something. The something that you are quadrupling is what it's equal to over here. So delta y gets multiplied by 4, or you could say it quadruples. This is plenty of verification to show what is occurring, and this is a lot shorter. I like to do this. This is the reason why I ask you to solve for the unknown variable, so that you can see proportionalities. When you double one thing, what happens to the other one? If the only thing we were to double was the time, well, we have a problem here. This is an up and down problem. If you double the time in the air, that's only possible by doubling the initial velocity. So this was a little bit on the tricky side because these two were linked to each other. Okay, I hope that helps.